So I wanted to make a little video to show off the OpenComputers program that I'm writing to manage basically power systems in TPPI2. And right now I'm just setting it up with Big Reactors because that's probably the most popular larger power system that people use. I haven't played around with the mechanism fusion reactor at all yet, so I don't know if I can control it through OpenComputers adapter blocks. Might be able to, we'll just have to see. So what I've got going on here is got one reactor and two turbines, and if you've ever set up just a standard passively cooled reactor, you've probably set one up like this before, where you can take two RedNet ports, and this one actually doesn't need to be connected there, and set one RedNet port to the energy output and the other RedNet port to the control rods. So if you turn the reactor on, it's basically going to moderate the control rods to the amount of power that is stored inside the energy buffer. And that works great, you know, for just your standard actively or passively cooled reactor. You don't need any computers or anything like that, unless of course you're running a very hot reactor like this stupid one that I threw together. But if you design the reactor right, that's really all you have to do is just connect those two together, and it will work perfectly efficiently by inserting the rods as the energy buffer goes up and down. But I wanted to design something that could do the same kind of thing with steam reactors. And the biggest problem with the steam reactors is the buffer tank inside them is very small. A max size reactor can produce, I believe it's around 50, or at a maximum of 50 buckets per tick. And that is the exact size of this tank here. So there is absolutely no way to moderate the control rods on a reactor like this when every tick it's outputting enough to fill this tank completely. And that became kind of a big issue. I tried regulating the control rods off the amount of steam that the turbines were using, but in order to regulate the control rods, you have to give it time to set the control rods correctly because the steam output doesn't change endlessly, and it basically led to the reactor overheating and burning a lot more fuel than it needed to. The other thing I tried was voiding the excess steam. The problem is that depending on how the chunks load in when you load into the game, it may load the tesseract first, or it may load the void pipe first. And so if it loads the void pipe first, it prioritizes that output on the reactor over the tesseract, and it voids all your steam, and none goes to the tesseract to the turbines. So I finally came up with this setup over here. I'm using these adapters from OpenComputers with tank controllers inside them, and they are hooked up to these bedrockium tanks. You could use any large tank. The larger the buffer, the better though, so personally I would only use either bedrockium drums or a very large, like a railcraft iron or steel tank. But the bedrockium drums are pretty cheap once you get a CobbleGen set up. And then I'm using these ultimate mechanical pipes from Mechanism, which are they're the highest output pipe that can pump that I've found inside the game. Tesseracts are great because they have an unlimited throughput, but they can't pump themselves. These Mechanism pipes can flow a maximum of, I think it's 64 buckets per tick, so one of those could handle your reactor straight to turbines if you wanted to. And they can pump up to 6.4 buckets per tick. Now again, the maximum that one reactor can output is 50 buckets per tick. So with 8 of these mechanical pipes pumping out of these two drums, I think it comes to about 52 buckets per tick that they're able to handle. So you want just enough, just a little bit above the capacity, the pump capacity of what the reactor can produce. And so what the program is doing is, let me turn stuff off here. So we'll turn this reactor off. I don't think it'll turn it back on now. And let me get a couple drums. And I'll go ahead and replace these. Oh, I need to break them both once so it drains out of steam. There it goes. Okay, so there's that, and let's see. Okay, yeah, that crash there because I removed the drums. Now these turbines, yeah, they're just gonna kind of wind down over here. So the first thing I can do is run the program, and it's going to find all the connected reactors, find all the connected turbines, find the tanks. That's the total capacity of the two tanks. And so right now it can tell that the turbines are running well below their optimal RPM, so it just disengages the coils because it's not going to be able to do anything, and it wants to keep them running if possible. So I'm going to go over here and turn this reactor on. And since those tanks, those steam tanks, are empty at this point, right now it pulls the control rods all the way out because it's trying to fill those tanks up. And you can see it's basically doing the same thing that we did with this little reactor over here with the energy buffer, but instead of using the steam buffer inside the reactor, it's so small, it's using these two bedrockium drums as a buffer. And as those tanks fill up, it will insert the control rods further and further. Now if we were to come over here and let's say we don't have any power usage going on, these energy buffers are going to start going up, and it sees, oh, okay, it's going up, don't need to produce any more power, so it's just going to disengage the coils, and that's it. And so you can see the tanks will continue filling up, and the control rods are continually going in. The other thing I did with this program is I wrote it so it goes through and it moves each control rod individually. Of course, it's not as fast as setting them all at once, but it allows you to get that one control rod set at 1% difference from the other, and that is what you need in order to perfectly regulate the steam. Versus if you try setting them all at once, it's usually going to produce, on a reactor of this size at least, it's going to produce about 600 millibuckets per tick, more or less than it needs to if you're only regulating the control rods by 1%. So I'm going to let these tanks fill up over here, and I'll come back in just a minute once they are. Alright, so now you can see these bedrockium drums are completely full of steam. And this is just real basic setup that I've got going on here. It's just displaying the RPM of all the connected turbines. The buffer tanks are completely full. And since the turbines, I made a mistake earlier and disconnected the tesseracts. I should have disconnected the power cables. Since the buffers are full, it has just completely shut off the steam input into the turbines. And since the buffers are full, on the turbines, those are shut off, these are full, and therefore if we go and look at the reactor, all the control rods are completely inserted, it's not using any fuel. Now if I come over here and let's say we have a partial load going on, so I'm just going to hook up one of those and let's break all but like 3 of those maybe. So the RPM dropped down to the point where it needed to open the steam flow, and it'll shut the coils off till the RPM drops down or the energy buffer runs out. And then once it gets up, I think I have it set to like 1825 is the max, it will shut the steam off and just let the kind of energy built up in the spinning turbine power it for a while. So the steam shut off and it's using the kinetic energy built up in the turbine to run. But once the RPM drops down, I think I would like at 1775, it'll open the flow of the steam back up. And if I come over here, well, I'm not going to hook all these test racks back up, that'd take forever to do, but this one really I don't think is being used for anything. So now it will just balance the load between the two turbines. This one is full, of course, so it's just going to take it up to the max acceptable RPM and then shut the steam off, and it looks like it's using this one right now. I've still got a lot of work to do on this program. I want to have it be able to optimize the use of certain turbines, like if you have a turbine with enderium coils versus a turbine with a lower tier coil. or Ludicrite. And this one, let's say was just like gold coils, it would optimize this turbine over the other because it's going to be more efficient to use the higher tier coils over the crappy one. And the other thing I want to do is have it so it will choose the most efficient reactor to use, so that you could have a very, very fuel efficient reactor set up to produce the amount of steam that you might need normally. But if you have a excessive need, it could turn on another not very efficient reactor, but a reactor that can produce a lot of steam. So a lot of work to still do on it, but I'm pretty happy with how it all turned out. The biggest point was figuring out a way to expand the steam buffer from the reactor itself, and I heated it up way too much because I disconnected the computer cable when I was filling up the drums all the way, so that's why it's hot. But you can see the temperature's dropping fast as it's pulling down, and so everything's stopped because it's really not using any power, and it's got the control rods completely inserted. And over time, well, actually, I guess really very, very little power is being used right now when it comes to those three. Yeah, these three over here barely using any power, so it's just going to sit here and not turn on at all, or it might have like one control rod running at 99%, I'm not sure. But it won't do anything until the steam buffer inside these drums drops. And I bet the reason those control rods are fully inserted is that it's just burning off, it's burning off a little excess heat right now. And that's still producing steam even though the control rods are inserted all the way. So I hope you guys like it. Like I said, it's still got a lot of work to do on it, a lot of features to add. It's definitely not ready to be, used by anyone yet because the setup is pretty involved, and it doesn't work in certain configurations. But I'll definitely be happy to share it once I get it all set up and working. Thanks for watching.